All right, so to finish up chapter 11, this video, we are not doing any new math. We're going to go through the same process that we went through with the examples last time. The difference is we are not getting our random numbers off of the pink sheet. We're going to be using the graphing calculator. But for me, it does not matter to me what method you use. So if you don't own a graphing calculator, you can use that pink sheet for as long as you need. So to access what's called the random number generator from the graphing calculator, you need to press the math button. You need to arrow all the way over to PRB. Let's change that color. And we need option 5. It'll say random int and it'll have just a parenthesis. This is what it'll look like in your calculator. What you're going to be typing in after that parenthesis is either 2 or 3 different numbers all separated by commas. Now, the reason I say 2 or 3 is it depends upon your situation. So let's talk about them. The first number is the lowest digit that you want. The second number is the highest digit you want. So for every single situation, you will always put in 2. You'll always have to establish your lowest and establish your highest. After that, the third digit is how many digits you want generated. Now, you're only going to use this for 2 specific situations. One, you're only going to use this if you need a set number of digits, like you are taking 10 free throws, or you're taking a test that has 5 questions. Okay, if you don't need a specific number of digits, like when we did the problem where you were shooting a 1 and 1, so sometimes you stop the first time, sometimes you stop the second time, or you're having babies until you have one boy and one girl. We didn't know when we stopped. You would not use that third one in that situation. You also only use this if replacement is okay. So if you had 20 people and you were choosing 4 people, yes, that's a set number of people, but you cannot repeat people. So replacement is not allowed, so you couldn't use that third pound. Okay, so only the first 2 pounds for most of these. And then all you simply do is press enter to generate the numbers. And once you set up the first random integers, you just keep pressing enter. You don't have to go back through this process. The only time you start this 1 through 5 process over is when you start a new problem. Other than that, if it's the same example or the same problem in your book, you just keep pressing enter and it'll spit out a new set of numbers every single time. So that's really the only thing new today. All we're going to do is we're going to practice 4 more examples, but a few of these are more challenging. So that's why I wanted to save these for the second day. So when drawing 5 cards randomly from a deck, which is more likely, 2 pairs or 3 of a kind? A pair is exactly 2 of the same denomination, and 3 of a kind is exactly 3 of the same denomination. Be careful, once you've picked the 8 of spades, you can't get it again in that hand. Okay, that was given to you so that you know that replacement is not okay here. Use 10 trials. So this is probably the most different kind of problem because we're focusing on a deck of cards. Well, a deck of cards has 52 cards in it, and each card is specific. And so we're going to number them each individually. So there is no percentages you need to look at because it's a set number of cards. It's kind of like the 20 people we did on that very first example. So let's look at our scheme. So our scheme, I'm going to label them through the different cards. Aces are going to be my first 4. So they are going to be 0, 1 to 0, 4. Twos are going to be 0, 5 to 0, 8. Threes are going to be 0, 9 to 12. Fours are going to be 13 to 16. Fives are going to be 17 to 20. 6s are going to be 21 to 24. 7s are going to be 25 to 28. 8s are going to be 29 to 32. 9s are going to be 33 to 36. 10s are going to be 10s are going to be 37 to 40. And then after 10, it jumps to a jack. So a jack is going to be 41 to 44. And then a queen is going to be 45 to 48. And kings are going to be 49 to 52. The reason I numbered them like that is because each deck has 4 of every item. Okay, and then I'm also going to throw a little note in here because suits don't really matter. Okay, that's the reason why I didn't go through and say the ace of spades, the ace of diamonds, the ace of clubs, because with pairs, you're just trying to get 2 of the same denomination. So the suits don't matter. Whoops. Okay, so that's our scheme. So our stopping rule. We are going to stop each trial after. How many cards are we drawing? We are drawing 5. And we're going to stop the simulation after, how many times are we running this? 10 trials. And this is after 5 cards. And our count. So trial 1, 2, 3, 4, and 5. 6, 7, 8, 9, and 10. Now, one thing we said that was important here is replacing is not okay. We can't reuse the same cards. But when we start each new trial, we assume all of the cards are back in there. So you just can't repeat cards in one trial. So let's talk about what your calculator would look like. So we're going to go to math. We're going to go over to PRB. We're going to choose option 5. And so in your random integer, your lowest card is 1, 0, 1, and your highest card is 52. And so all you're going to do is, because we're not going to use the 5th one, the reason for that, we can't repeat. All you have to do is press enter. If a number repeats, just don't use that number. Just press enter until you get a clean number. And you're just going to keep doing that until you've gotten 5 numbers each time. Now, because you might be using a calculator that's different than mine, you're going to end up with different numbers. So you can either use my numbers or you can use whatever your calculator spits out. So I have my calculator ready to go, and I'm going to press enter, and my numbers are 7, 16, 20, 33, and 26. And all I have to do is keep doing that to get 5 cards each time. So my next one, 41, 37, 19, 36, 30. Notice it's okay if we have repeats between trials, just not within the same trial. My next trial was 3, and then 39, and 18, and 23, and 11. And that should be a 0, 3. And then I had 0, 1, 26, then 16, 32, and 24. And so what I want you to do is pause the video, use your calculator or your pink sheet, and finish filling this in. Okay, so the rest of my trials were 45, 17, 28, 51, and 2. And then 25, 39, 10, 19, 17, 10, 29, 11, 39, 46, 2, 25, 14, 17, 33, 40, 26, 27, 41, 23, and 44, 37, 1, 0, 1, 27, 34. So what I'm going to do is I'm looking for numbers that are right next to each other, and then I'm going to look up at my scheme and see if they match up. So like if I look through this first trial, none of those are next to each other. So I got nothing there. Looked at my next trial, nothing. I have a 37 and a 36. So are those next to each other? So I'm going to go up to my key. 36 is a 9 and 37 is a 10. So those don't match. I look through my next group and I see nothing next to each other. My next group, 24 and 26 are close together. So are 24 and 26 together? No, 24 is a 6 and 27 or 24 is a 6 and 26 is a 7. So again, they don't have to be right next to each other, but very close because we're looking at like little groups of 4. So I look at the next one, nothing close to each other. The next one, 17 and 19 are close. Are they in the same group? They are. 17 and 19 are both 5s. So that is a pair. But I don't have any other ones that are pairs. In the next group, I have 10 and 11. Are they from the same ones? 10 and 11 are both 3s. So those are a pair. My next one are 14 and 17 in the same group. No, 14's a 4 and 17's a 5. My next one, I have 40 and 41. Those are not in the same group. 40 is a 10, 41's a jack. What about 26 and 27? Those are 7s. The next group, I have 37 and 34. Are those in the same group? No, they are not. 37's a 10 and 34 is a 9. So there's all of my ones that actually follow the rules, because the rules were a pair is exactly 2 of the same denomination, and 3 of a kind is exactly 3 of the same denomination. So I have no 3 of a kinds, but I do have some pairs. So my pair, my pairs, how many do I have? I ended up with 3 trials out of 10 that were pairs. 3 of a kind, I ended up with 0 trials out of 10 that were 3 of a kind. So obviously, which one is more likely? Pairs are more likely. Okay, so let's look at the next. 20% of cereal boxes contain a picture of Tiger Woods, 30% David Beckham, and the rest Serena Williams. Suppose you buy 5 boxes of cereal. Estimate the probability that you end up with a complete set of pictures. Use 20 trials. Because this is a video and it's time, we're going to change that to 10 trials. So we have 3 people here. We have Tiger, we have Beckham, and we have Serena. So it says Tiger Woods is 30%, so that's 30 out of 100. David Beckham is, Tiger was 20%. I misread the wrong number. Tiger's 20 out of 100. David Beckham was the 30 out of 100. And Serena's the rest. Well, Tiger and David together is 50. That means that Serena is 50 out of 100. So we want to reduce these. Remember we talked about if we can reduce them out of 10, we're happy. So we can. This one reduces to 2 out of 10. And this one reduces to 3 out of 10. And that one reduces to 5 out of 10. So we're going to leave those all as 10s. So let's talk about our scheme. So, Tiger, we need 2 numbers for. David, we need 3 numbers for. And Serena, we need 5 numbers for. So, we always start with 0. So, Tiger's going to be 0 and 1. David's going to be 2, 3, and 4. And Serena's going to be 5 through 9. And is it okay to end up with the same person more than once? Yes. So replacement is okay. So when do we stop? We stop each trial after how many cereal boxes? It says we buy 5 boxes. And we're going to stop the simulation after 10 trials, because I said let's save time for the video. All right, so let's look at our count. So trial 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so what are we going to type in the calculator? So we're doing random integer. My lowest number is 0, comma. My highest number is 9, comma. This time I am going to use a third digit because I need specifically 5 boxes and repeats are okay. So I'm going to put a 5 there and close parentheses. So when I hit enter, it's going to spit out 5 numbers and I write those 5 numbers down. So enter and I got 5, 2, 5, 3, 7. Hit enter again, I get 3, 7, 4, 5, 9. Hit enter again, I got 0, 9, 1, 2, 7. And I want you to pause the video and finish filling these in. All right, I got 5, 8, 0, 3, 3, 5, 5, 5, 3, 3, 3, 4, 4, 9, 7, 2, 2, 2, 2, 0, 3, 1, 8, 3, 0, 5, 0, 3, 7, 2, 0, 6, 0, 2, 9. Okay, so we are focusing on estimate the probability that you end up with a complete set of the pictures. So I need all 3 people. So I'm going to go through and I'm just going to put little stars next to my ones that have all 3. So the ones that I look for first are the 0 through 4. So like 0 and 1, there's no 0 and 1 in the first one, so this one doesn't work. Second one also does not have a 0 and 1. The third one has a 0 and a 1, so it has a tiger. It has 2, it has a David, and it has a 9 and a 7, so it has a Serena. So this one has all 3. The next one, 0 is tiger, 3 is David, 5 and 8 are Serena. The next one has no 0s and 1s. Trial 6, no 0s and 1s. Trial 7 has 0 that's tiger and 2 that's David, but no Serena. Trial 8 has 0, which is tiger, 3, which is David, and 8 that's Serena. Trial 9, 0 is tiger, 2 and 3 are David, 5 and 7 are Serena. The last one, 0 is tiger, 2 is David, 6 and 9 are Serena. So, how many ended up with all 3 people? I see a total of 5 stars out of 10, so the probability of getting all 3 if you buy 5 boxes is 50%. Let's look at the next one. This is probably the most challenging one out of all of them. Assume that your chance of passing the driver's test is 34% the first time and 72% for subsequent retests. In other words, after you fail the first time, your chances go up. Estimate the percentage of those tested who still do not have a driver's license after 2 attempts. So our scheme is going to have to be very specific because we have first attempt percentages and second attempt percentages. And because these percentages are 72 and 34, I'm just going to stick with out of 100. So let's talk about our scheme. So let's focus on our first attempt of passing or failing. So on your first attempt, the chances that you pass on your first attempt is only 34%. and that was on the first time, and then 72% for the other ones. So 34%, I need 34 numbers for passing. So that's double zero through, remember, one less, 33, which means failing is 34 to 99. But on the second attempt, our passing percent and our passing is now 72. So passing is going to be 0 to 71, and failing is going to be 72 to 99. So when do we stop? We are going to stop after, we're going to stop each trial either after you pass or 2 fails. And we're going to stop the simulation after 10 trials. All right, so let's look at our count. Trial 1, 2, 3, 4, and 5, 6, 7, 8, 9, and 10. So we have to pause each time and decide on the first attempt, did they pass or fail? So my first number, let's talk about the calculator. So random integer, our lowest number for everything is 00, and our highest number is 99. Because we don't know whether you're going to take it 1 time or 2 times or 3 times. We're stopping with 1 number each time. So I'm going to hit enter, and it spit out a 98. So if we look at the first attempt, that's a fail. So I'm going to take it again, hit enter, and I got a 17. Doesn't matter what they do on the second one, we're just going to move on. First time I got a 90. That is a fail, so I'm going to hit enter, and I get an 18. First, hit enter again, I get an 11. That is a pass, I'm done. Hit enter again, I got an 18. That's also a pass, I'm done. Enter again, 15. That's a pass, I'm done. 30, that's a pass, I'm done. 17, that's also a pass, I'm done. 74, that's a fail. Hit enter again, I got an 83, done. 85, check, that's a fail. Hit enter again, I get 74, we're done. And finally 16, which is a pass. So now I need to see which ones were passes. And so this one, if I go back to trial 1, 17 on the second attempt was a pass. 18 on the second attempt was also a pass. All of the single ones were passes. Trial 8, 83 on the second attempt was a fail. 74 on the second attempt was a fail. And 16 was an automatic pass. So, it wants us to estimate the percentage of those tested who still do not have a driver's license after 2 attempts. So the ones that still don't have licenses. So that would be the fails. And so if we look, we had 2 fails out of 10, which is 20%. And let's look at the last example. You are 3 spaces from the win in Parcheesi. On each turn, you will roll 2 dice. To win, you must roll a total of 3 or roll a 3 on one of the dice. How many turns might you expect this to take? Use 10 trials. So we don't have percentages this time because we're focusing on dice. So our scheme is going to be focused on dice. Well, we are rolling 2 dice. Each dice has the numbers 1 through 6. So our numbers are going to be 1 through 6. And we are allowed to repeat numbers, so replacement is okay. So when do we stop? Whoa, not stop, stop. We're going to stop each trial with either a total of 3 or the number 3 on one of your dice. When are we going to stop the simulation? We're going to stop the simulation after it says 10 trials. Okay, so let's look at our count. I'm going to put a few more down here since I have space. So let's talk about what the calculator is going to say. Okay, so random int, our lowest number is 1, highest is 6. We needed to, since we have 2 dice, every single time we needed to spit out 2 numbers. So we can examine the 2 dice. So I'm going to hit enter. My first pair was the pair 2, 4. So the total is 6, and we didn't get the number 3, so we have to hit enter again. So trial 1 is not done. 6 and 6. Those also don't total 3, and they don't have the number 3, so I'm going to hit enter again. 1, 4. Those do not total 3, and those do not have a number 3. 4, 3. There's my number 3. I stop. So it took me a total of 4 turns to finish that trial. So that's the concept. So I'm going to hit enter to start the next one. 1, 5. No 3s and no total of 3. 4, 5. No 3 or no totals of 3. 5, 3. There's a 3. I'm done. Next trial, 1, 1. Those total 2. 3, 3. Perfect. Lots of 3s. We're done. Trial 4. 4, 4. No good. 1, 3. We're good. Trial 5. 2, 5. No good. 3, 2. That one works. Trial 6. 6, 1. No good. 1, 4. No good. 5, 3. Good. Trial 7. 3, 1. Done on the first one, we win. Trial 8. 5, 3. No good. Trial 10. 5, 3 was good. Trial 9. 1, 2. That's actually good. That's an example of a total of 3 because 1 plus 2 is 3. Last trial. 4, 2. I have no good. 5, 5. No good. 4, 2. No good. 4, 6. No good. 1, 1. No good. 5, 6. No good. 5, 5. No good. 4, 5. No good. 4, 4. No good. 1, 1. No good. 6, 6. No good. 4, 4. No good. 5, 2. Wow, this is going on forever. And 6, 3. Finally. Holy cow, that one took forever. So now what we need to figure out is, because it wants to know how many turns might you expect this to take. So the first trial took 4 turns. Second trial, 3 turns. Second trial, 2. Fourth trial, 2. Fifth trial, 2. Sixth trial, 3. Seventh trial, 1. Eighth trial, 1. Ninth trial, 1. 10th trial, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So how many turns do you expect this to take? That's another way of asking for the average number of the average number of turns. 4 plus 3 is 7, plus 2 is 9, plus 2 is 11, plus 2 is 13, plus 3 is 16, plus 1 is 17, 18, 19, and 19 plus 14, I get 33. Divided by, we had 10 trials. So it's going to take about 3.3 turns to win the game. And that's the end of chapter 11.